Dear students, in this lecture, we will learn mathematical properties of arithmetic mean. Its first property is that sum of deviations taken from arithmetic mean is always 0. That is, sigma x minus x bar is equal to 0, while sigma mean is summation, adding up of values of a given variable. It means that when the different values of variable x is subtracted by value of arithmetic mean, their addition, their summation will be equal to 0. उसका जो एडिशन होगा वो 0 के बराबर होगा. And second property is that sum of square deviation taken from arithmetic mean is minimum. When it is taken from arithmetic mean, then its value will be always minimum as compared if it is subtracted by assumed mean. In place of arithmetic mean, if we take the value of assumed mean, where a is assumed mean, it is means that sum of square deviations taken from assumed mean, it will be always greater than sum of square deviations taken from arithmetic mean, which will be minimum. Now we will prove this with the help of given example. हम example लेंगे, उस example के मदद से हम इसको prove करेंगे these two properties of arithmetic mean. For example, the variable is denoted by x. It may be any variable such as income, wage, age, height, marks, etc. And its values are 10, 20, 30, 40. Now from this data, we have to prove these two mathematical properties of arithmetic mean. Now the solution will be like this. In the first column, we will take the value of variable x, different values of variable x, which is 10, 20, 30 and 40. And it is summation, that is sigma x, it will be equal to 100. In the next column, we will take the values of, we will obtain the values of deviations taken from arithmetic mean, that is x minus x bar. Therefore, first we have to calculate arithmetic mean, that is x bar arithmetic mean. It will be calculated in case of individual series with the help of this formula, sigma x, that is summation of values of variable x divided by number of observations, total number of items in a given series, sigma x, which is equal to 100, and total number of observation, total number of items in a given series are 1, 2, 3 and 4. and it will be equal to 25. Therefore, x bar is equal to 25. That is, arithmetic mean of this data is 25. While x bar is equal to 25. Now, subtracting the values of variable x by arithmetic mean, that is 25, we will get the values 10 minus 25, it will be equal to minus 15. 20 minus 25, it will be equal to minus 5. 30 minus 25, it will be equal to 5. 40 minus 25, it will be equal to 50. And it is summation, that is sigma x minus x bar, it will be equal to their summation minus 15 minus 5, it will be equal to minus 20. Minus 20 plus 20, it will be equal to 0. That is, and from this it is proved that sum of deviations taken from arithmetic mean is always equal to 0. This is the first property. Now we will prove second property of arithmetic mean, that is sum of square deviations taken from arithmetic mean, it is always minimum. Now our next column will be to get the values of sum of square deviations, that is x minus x bar, it is whole square, and it will be equal to 15 into 15 minus 15 into minus 15, it will be equal to 225 minus 5 into minus 5 to square of these values, it will be equal to 25 and 225, and sum of square deviations, it will be equal to its summation will be equal to 500. Now we will prove it that if sum of square deviations taken from other values such as assumed mean, it will be always greater than sum of square deviations taken from arithmetic mean. Now therefore, in the next column we will take x minus a, where a is assumed mean and x is a variable having different values. Suppose we will take assumed mean, we can take any value as assumed mean. Suppose we will take assumed mean equal to 20. A is equal to 20. Now its values will be 10 minus 20, it will be equal to minus 10. 20 minus 20, it will be equal to 0. 30 minus 20, it will be equal to 10. 40 minus 20, it will be equal to 20. And its summation will be equal to summation of these values, that is sum of deviations taken from assumed mean, sigma x minus a, it will be equal to 30 minus 10, it will be equal to 20. If it is taken from arithmetic mean, its value will be equal to 0. Sum of deviations taken from arithmetic mean is always 0, the first property. And if it is taken from assumed mean, it will not be equal to 0. Now it is first property is proved here. And the second property will be proved with the help of taking square of these values. x minus a, its whole square, it will be equal to 100, 10 into 10, 100, 0, 100, and 400. Sum of square deviations taken from assumed mean, while a is assumed mean, it is total will be equal to 600. Sum of square deviations taken from arithmetic mean, which is equal to 500, and sum of square deviation is taken from assumed mean, which is equal to 600. Therefore, sum of square deviation is taken from arithmetic mean, it is minimum, as proved in this example. With the help of this example, we have proved these two properties of arithmetic mean. The first one, sum of deviations taken from arithmetic mean is always 0. Here you will find it. And sum of square deviation taken from arithmetic mean is minimum. Here it is proved that sum of square deviation taken from arithmetic mean it is 500, and sum of square deviation taken from assumed mean from other value it is 600. Means from arithmetic mean it is minimum as compared to taken from other values such as from assumed mean. Now we will learn one more property of arithmetic mean, that is the third property of arithmetic mean is that if the values of variable or if the values of given item are replaced by values of arithmetic mean, value of arithmetic mean, its sum will be equal to the sum of individual values of variable. Now we can also prove this with the help of some example. For example, हमारे पास जो डेटा है वेरिएबल है वो है वेरिएबल x, और इसके जो वैल्यूज है वो है 10, 20, 30 and 40. Now solution will be the values of variable x are 10, 20, 30 and 40. At summation of these values, their sum, their addition, that is sigma x, it will be equal to 100. Now its arithmetic mean will be equal to sum of these values divided by total number of items, total number of observations in a given series. Sum of these values, that is sigma x, it is equal to 100, and total number of observations, total number of items in a given series, this is the individual series, their total number is 1, 2, 3 and 4, and value of arithmetic mean it will be equal to 25. Now if we will replace these values 10, 20, 30 and 40 by the value of arithmetic mean, the sum of these values arithmetic mean values, it will be equal to the sum of these individual values of variable, that is equal to 100. Now we will take the values in place of these values, that is value of arithmetic mean. We will replace these values by the value of arithmetic mean, that is 25 that we have calculated earlier. Now x bar, which is the arithmetic mean, and its value is 25 in this example. Now we will replace these values of variable x by the value of arithmetic mean, that is 10 will be replaced by value of arithmetic mean, that is equal to 25. 20 will be replaced by the same value 25, and 40 will be also replaced by the value of arithmetic mean, that is 25. Now sum of these values, the values of arithmetic mean, it will be equal to 100. This is the third property of arithmetic mean, that is, if the values of variable are replaced by value of arithmetic mean, its sum will be equal to the sum of individual values of variable. This is shown in this example, that the values of variable x are replaced by the value of arithmetic mean, that is 25 in our example, and sum of both, that is sum of individual values of variable, which is equal to 100, and the sum of values of arithmetic mean, it is also equal to 100. Therefore this third property is also proved with the help of this example. I hope you have got it. Thanks.